Okay, recording started. We'll continue the lab session. Okay, so from next week onwards, we will be having 1.5 hour theory session in the morning and 45 minutes lab session in the evening. Okay, 3:30 to 4:15 we will be having. Fine. Okay, now in today's class we are going to discuss about the third experiment. Okay, we have posted the observation submission assignment, okay, in your respective Google Classroom. Kindly go through it. Okay, so 14 days time கொடுக்கிறோம் ஒவ்வொரு observationக்கும் 14 days time கொடுக்கிறோம். Fine. So similarly record we will give you some time. So record பொறுத்த வரைக்கும் இப்போ நீங்க யூனிட் டெஸ்ட்லாம் எழுதுனீங்க இல்லீங்களா, அதே மாதிரி we will send you some document in the Google Classroom. We will post some documents in the Google Classroom. Record experiment 1, 2, 3 like that we will post. So அந்த டாக்குமெண்ட்டை டவுன்லோட் பண்ணி நீங்க என்ன பண்ணணும், you have to write whatever it is there in the record note. Okay, ஒரு record note ஒன்று போட்டுக்கோங்க. It should be maintained properly. Okay, you have to taken care of that. Okay, at any point of time we may ask you to submit that record note. Fine. So அதனால record note ஒன்று போட்டுக்கோங்க. Record material we will send you. Just you copy all those things. Okay, then you fill the truth table, input, output, circuit diagram, everything. Okay, fine. Now we will go with the third experiment. Half adder, full adder, half subtractor, full subtractor. Today's experiment we are going to discuss. So idhula vandu nama half adder, full adder we will be doing. Half subtractor, full subtractor you people can do on your own. Fine. Okay, so this is our third experiment. Before getting into this experiment, what is the aim of the experiment? To design and implement half adder or subtractor, full adder or subtractor using digital logic gate. Don't think it is half adder come subtractor. Okay, so here for simplicity they have mentioned like this. Actually half adder, full adder, half subtractor, full subtractor, 4 combination logic circuit we are going to design. Fine. So now we will go with the prerequisite question. What is the function of half adder? What is the function of half adder? Can you people type it in the chat? What is the function of half adder? Name itself we have. It is going to perform what? See, kindly interact. Addition. Okay, it is going to perform addition. Very good. How many bits it is going to use for adding? How many number of inputs must be there in the half adder? Yes, 2. Fine. So to add 2 bits and provide 2 outputs, sum and carry. Fine. What is the function of full adder? How many number of bits it is going to add? Yes, 3 input. Fine. 3 bits, the same output, sum and carry. Fine. How many half adders are required to design a full adder? Can you people type it in the chat? Yes, 2 half adders are required to design a full adder. Whether half adder alone is enough, half adder mattum poruma, any other additional component we need to design a full adder? Very good, Jivita. We need OR gate. Fine. So 2 half adders with 1 OR gate to develop or to design a full adder. So draw the logical block diagram of full adder circuit using half adder. This is frequent 2 mark question la kepom. Fine. So as of now, straight away we can go with the answer. Is it clear for all of you? Idu purinjudha ellarkum? When we are performing 3-bit addition, okay, first 2 bits la carry vanda varalam, illa enna varalam, second 2 bit, that means first sum oda third bit add பண்றப்ப carry வரலாம். Fine. ரெண்டுத்துலயுமே carry வர possible இல்ல. Already இது நிறைய தடவை சொல்லியிருக்கோம். I will go with one example. Say for example A equal to 1, B equal to 1, C equal to 1. Fine. So can you type it in the chat? What about the answer for or the output of first half adder? I am naming 1 and 2. Half adder 1, half adder 2. What about the output of carry and sum? Sum and carry? Yes, both are 1. So carry equal to 1, sum is equal to 1. Now, with this sum, the sum இருக்கு இல்லைங்களா, இது கூட நான் என்ன பண்ண போறேன்? Cn, that means the third bit I am going to add. So what about the output I will be getting here? Correct அப்பா? 1 1 add பண்ணா 1 1 வருமா? Correct தப்பா? Yes, very good Srihari. Srihari correct சொல்லியிருக்கிறாரு. It is not 1 1. Correct? 1 plus 1 is sum is 0. Okay. Sum கண்டிப்பா எனக்கு என்ன வரணும்? 0. Carry எனக்கு என்ன வரணும்? 1. Now, with this sum, I am going to add the third bit. 0 or, that means 0 plus 1. என்ன கிடைக்கும் எனக்கு? Sum 1, carry வந்து எனக்கு என்னது? 0. You people conclude one thing from this. During first 2-bit addition, I will be getting carry. If I am getting a carry here, definitely I won't get a carry here. ஒன்னு இங்க கேரி வந்தா இங்க வராது, ரெண்டுத்துலயும் வராமையும் இருக்கலாம். எப்படி ரெண்டுத்துலயும் வராம இருக்கலாம்? ஃபர்ஸ்ட் இது பார்த்து முடிப்போம், then we will go. If any one of the half adder is generating carry, the final carry is equal to 1. Cout is equal to 1. So that's why we are using the half adder with the OR gate for generating the carry out. Okay. Now you imagine some other input combination. Say for example, A equal to 0, B equal to 0, C equal to 1. So how we will be getting the output? So here carry is 0, sum is also 0. Fine. 0 plus 1 is sum is 1, carry equal to 0. In this case, both carry out is 0. So final carry is 0. So now you can check the output. 0 plus 0 plus 1. What meaning is sum 1, carry 0. Clear for all of you? Is it clear for all of you? Okay, fine. Can you people type the answer for the first boxes? 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. You just type the sum alone. Carry பத்தி worry பண்ண வேணாம். Sum மட்டும் என்னென்ன வரும் type பண்ணுங்க. 0 plus 0 is yes. 0, 1, 1, 0. Very good. Super. What about for the second one? Difference எப்படி வரும்? Difference மட்டும் type பண்ணுங்க. போரும். In that case also 0, 1, 1, 0. Fine. ரெண்டுத்துலயுமே எனக்கு என்ன வருது? சம்மும் கேரியும் நமக்கு என்ன வருதுப்பா? So here it is termed as sum. இது alignment மாறி இருக்கு. Sorry. Wait a minute. Here it is considered as sum. இது sum. Okay. So இங்க வந்து பாத்தீங்கன்னா here it is considered as difference. Clear? ரெண்டுத்துலயும் எனக்கு என்ன கிடைச்சிருக்கு? 0, 1, 1, 0. இங்கேயும் 0, 1, 1, 0. இங்க கேரி எப்ப எனக்கு 1 வருது? 1 plus 1. இங்க 0 minus 1 பண்ணா borrow வரும். That's the difference. Fine? Okay. So what are the gates we are going to use? XOR gate. கண்டிப்பா XOR gate use பண்ணணும். AND gate, OR gate, NOT gate. All the 4 gates we are going to use. Then switches for input and LED or bulb for output. Okay. Kindly take a screenshot of this. See, இங்க நம்ம சொல்லி கொடுக்கிற prerequisite question தான் maximum எனக்கு எங்க வரும்? Observation submissionல வரும். Fine. Maybe ஒரு சேஞ்சுக்காக என்ன பண்ணலாம்? What are all the given components are required to perform this experiment? அப்படின்னு கேட்டு இந்த மாதிரி காம்பனன்ட் யூஸ்டு லிஸ்ட் பண்ணிடலாம். தேவையில்லாத காம்பனன்ட்டும் அது கூட கொடுத்துடலாம். நீங்க எதெல்லாம் வேணுமோ அது மட்டும் என்ன பண்ணணும்? You have to properly select it. Fine? Okay. Now I will move to the next slide. So இது நம்ம எல்லாருக்குமே தெரியும். Fine? OR gate அப்படின்னு சொன்னோம்னா the layout will be like this. Sorry, this one is XOR gate, not OR gate. This one is XOR gate. Kindly take a screenshot if it is needed. இல்ல சார் நிறைய தடவை நான் இது ஸ்கிரீன்ஷாட் எடுத்துட்டேன் அப்படின்னா you can straight away use. No problem. Shall I proceed to next slide? Yes? Okay. So this is the pin layout of AND gate. கொஞ்சம் கடகடன் ஸ்கிரீன்ஷாட் எடுத்துக்கோங்கப்பா. I will move to next slide now. Okay. 7432 OR gate. Okay, next 7404 NOT gate. Hex inverter. This circuit we call it as hex inverter. There are 6 NOT gates. Hex means 6. That's why we say hexadecimal. That means 16 symbols will be there in hexadecimal. Okay, kindly take a truth table of half adder circuit. The slide ellame konjam kada screenshot edukonga. I will wait for 10 seconds, 5 to 10 seconds. Okay, I will move to next slide. Kindly note down this circuit. This is rombo mukkiyam. This circuit only we are going to build. Okay, we are going to build this circuit only. Shall I proceed to next? Yes. So this is the circuit of full adder. I think order change aidichu nenikiren. So this is the truth table of full adder. Okay, iதை note பண்ணிக்கோங்க. Then this circuit, kindly make a note of it. So half adder, full adder தான் நம்ம பண்ண போறோம் இப்போ லைவா. Okay, half subtractor, full subtractor, you people are going to do. Okay, fine. So truth table of full adder. Next, half subtractor. So this is the truth table of half subtractor. Kindly take a screenshot. Okay, next, this is the circuit of half subtractor. So this circuit you are going to implement. And finally we are having full subtractor. This is the truth table of full subtractor. Kindly take a screenshot. And this is the circuit of full subtractor. Fine. So full subtractor circuit now perform பண்றதுக்கு எனக்கு என்னென்ன gates வேணும்? AND gate, OR gate, NOT gate, XOR gate. எல்லா கேட்டுமே தேவைப்படும். Fine. See, when you are doing in real lab, people will struck with this particular experiment. Okay. Why? 4 ICs I have to use for this particular experiment. So it is a little inconvenient for you people when doing in real hardware. Okay, because you have to remember, எனக்கு இந்த particular XOR gateல 2 IC இருக்கா, so எந்தெந்த XOR operation, எந்தெந்த gates நான் யூஸ் பண்ணியிருக்கேன், that we have to remember. Fine. Okay. Now we will proceed with Logic Circuit Simulator Pro from my mobile phone. So now I am going to stop the presentation from the from the system. So I'm going to present from the mobile phone. Okay, fine. So from now I'm going to present the screen from my mobile phone. Wait a minute. Wait for some time. Okay. Is the screen is visible? The screen is visible for all of you?
Yes, Ram sir, visible.
Yes?
Yes, sir.
Okay. Fine. So now we will go with the simulator software. Okay, as usual I will do with logic gate, then we will proceed with the ICs. Okay, so first I am going to open a new project. So for performing the or for implementing the half adder circuit, what are the components we need? என்னென்ன components எனக்கு வேணும்பா half adder க்கு? Diagram பார்த்து சொல்ல முடியுமா? See, my mobile phone is running out of memory, so I may not able to open the PPT. Fine. AND gate, OR gate. Devadani, whether it is OR gate, yes, Sabarisati, XOR, OR gate, switch, LED. Okay. Jayavadini, I think it is XOR gate. You try to type. Yes? So AND gate XOR gate venum. Correct? Fine? Okay. So I can project only from one device. Okay. For our system, anyhow, I will try to show you. Okay. Now I am going to stop presenting from my mobile phone and I am going to present from my system. See, கொஞ்சம் note பண்ணி வெச்சுக்கோங்க. Circuit diagram மட்டும் கொஞ்சம் note பண்ணி வெச்சுக்கோங்க. Okay. So later point of the time நமக்கு இது எப்பவுமே தேவைப்படும். So we are having one XOR gate and one AND gate. Fine. So now I am going to present from my mobile. Stop sharing. Okay. I am projecting my mobile phone screen. Fine. Okay. So now I am going with the software. So எனக்கு ஒரு XOR gate வேணும், ஒரு AND gate வேணும். Fine. So I am going to component menu. I am selecting one XOR gate and one AND gate. Fine. Then two switches we need for providing the input and two lights we need. One for sum and one for carry. Fine. All the components I have taken. So AND gate. We are having XOR gate. So we are having two outputs. I am just simply placing in such a way that how the circuit looks in the diagram. So முடிஞ்ச அளவுக்கு அதே மாதிரி அரேஞ்ச் பண்ணிட்டீங்கன்னா ஈஸி ஆயிடும். So we are having two input switches. So one we have told us A. Okay. So one we term it as A. The other one we term it as B. Label la போயிட்டு டைப் பண்ணிக்க வேண்டியதுதான்ப்பா. So this one we term it as B. Fine. Okay. Then output. This one I am going to term it as sum. So S for sum. This one we are naming it as C. C for carry now. Or simply we can say C out. C we can use C. So I am going to connect the circuit. XOR gate எடுத்து கொடுத்தாச்சு. Now we are going to provide. Okay. Can you people type it in the chat whether the circuit is understand by you or it is something like very confusing? Can you people type it in the chat? இத பார்த்தா ஏதாவது புரியுதா அந்த சர்க்யூட்டை பார்த்தா? Is the paths are very clear? Yes or no? இந்த சர்க்யூட்ல உங்களுக்கு அந்த பாத் எல்லாம் ப்ராப்பரா இருக்குதா? No. So what we can do? Yes, we can use node. Very good. So what I am going to use is at least for each one input or output we can use nodes. Okay. Node நம்ம யூஸ் பண்ணா என்ன பண்ணுப்பா? You have to go for component list, select node. So I am having one node. I am placing somewhere. Now node connected with A, that should be connected like this. So now what I can do? I can drag the node anywhere. Like this we can do. You can zoom it and you can move freely. எங்க வேணா move பண்ணிக்கலாம். Fine. So one more node I am going to take for B. Connect. So I am going to move it. See, zoom பண்ணீங்கன்னா நீங்க கிளியரா எப்படி வேணா மூவ் பண்ணிக்கலாம். Fine. ஒரு இன்புட் டிவைஸுக்கு ஒரு நோடு போறோம் மேக்ஸிமம். Fine. So now I am going to connect from Now I am going to connect from A2 first input of AND gate, then B2 second input of AND gate. For output also we need nodes. Okay, output nodes use proper. Fine. So I'm going to select two nodes, one for sum, okay, the other one for carry. Just place node adjust it's very simple. See, first time I struggled, correct? So familiar meaning in you have to practice more, that's it. That's all. Now you type it in the chat whether the circuit is having some clarity in the connection. So neenga submit pannakuriya circuits ellame nodes kandipa use pannunga. Okay, then only the circuit will be proper. Is it now okay? Yes, okay. So now I am going to simulate. So touch nama click paniyachi. Fine. So the truth table I hope everyone know. So 0 0. What about the output? Sum 0, carry 1. So now I am going to give the input as 1 1. Can you people type the answer for 1 1? A equal to 1, B equal to 1. Kudutha output enna varum? A equal to 1, B equal to 1 kudutha sum enna varum, carry enna varum? What about 1? What about 0? For what? 1. For what? It is 0. If I give the input as S is equal to 0, sorry, A equal to 1, B equal to 1, what about my output? Yes, carry equal to 1, sum equal to 0. So both input, if I am giving 1, you can see sum is equal to 0, carry equal to 1. Is it clear for all of you? Is it clear for all of you? Yes or no? Yes, fine. Okay, students, can we make this as a block diagram? The block diagram convert pannalama? Try panni paakalama? Yes? Okay. So for that what we have to do? We have to go for setup. So setup poningna project ku innum na name e kudukala, correct? First project ku or name vechillam. Fine? If I click on the three lines in the top right corner, save symbol ku pakkathula ulladha click pannona project 36 irka. So I am going to name it as HA nu vechikalam. HA appadina meaning enna? Half adder. I am simply naming it as HA. Now click on setup. Okay, add IO connection. What are the two inputs? A, add IO connection. B, renduthiyum nama kuduthachu. Fine. So first one I am going to rename it as IO14 irukku illingala. So adha na enna panna poren? I am going to rename it as A. What about the second one? I am going to rename it as B. Fine. Similarly, add IO connection. Sum, it is one output. Fine. So I am going to rename it as sum. Yes. Okay. Then add IO connection. C. Fine. I am renaming that also as C. Can you people type? What about the orientation of the outputs in the given diagram? Left side la irukku. Endha pakkam irundha nalla irukum. To which side I have to move the sum and carry so that the block looks like proper? Yes, Jeevitha. So to move it to right side, S ku nera enna irukku? Left. You click top and maruncha, again you click, it become right. Similarly, carry. Is it okay now? No subtractor. In Tinkercad, no half adder, full adders we are having. We have to form everything using the IC. Then the IC vechi da nama form panna mudiyum. Fine. So anga vandu indha mari oru provision kedaiyadhu. Fine. See, this particular software, it is having some advantage. Whatever the thing you want to design, actually you can work it with a simulation. Okay. So complex circuit na enna pannalam? Blocks ah convert pannittu easy ah use pannikalam. Fine. Is it clear for all of you? Now the circuit is ready. That means the IC is ready. So half adder நானா என்ன பண்ணிருக்கேன் ஒரு IC வந்து ரெடி பண்ணிட்டேன் கரெக்ட்டா fine now I am going back so HA நல்லா கவனிச்சீங்கன்னா தெரியும்பா you can see a triangle available IO இருக்குதுங்களா is it there or not whether it is available for some other projects yes full adder இதுக்கு இருக்குது clear only few of the thing is having available IO is it clear பார்க்க முடியுதா உங்களால that means those projects can be used as an IC in other project வேற ஒரு ப்ராஜெக்ட் நான் கிரியேட் பண்ணேன் அப்படின்னா அதுல நான் என்ன பண்ணிக்கலாம் இந்த பர்టిక్యులர் ப்ராஜெக்ட்ஸை ஐசிஐ யூஸ் பண்ணிக்கலாம் ஃபைன் ஓகே நவ ஐ அம் கோயிங் டு பெர்ஃபார்ம் ஃபுல் ஆடர் சர்க்யூட் ஃபுல் ஆடர் சர்க்யூட் நம்ம என்ன சொல்லியிருக்கோம் ரெண்டு ஹாஃப் ஆடர் வச்சு பார்க்கலாம்னு சொன்னோம் கரெக்டா do you remember I will show the diagram I will stop presenting from my mobile phone I will show the diagram then I will come back here okay I am going to present from the computer yes you can see this block kindly note down this block clear now I am going to implement this circuit only fine shall we proceed yes note பண்ணிட்டீங்களா இந்த சர்க்யூட்டை ரெண்டு half adder இருக்கு கரெக்ட்டா sum of first half adder is given as input to second half adder with the third input find the final output from the second half adder sum it is the final sum then carry of both the half adder should be perform OR operation clear shall we proceed okay so now I am going to stop presenting from the computer so I am going to present from my mobile phone again see why this much of things we are doing for your understanding only தியரியில நீங்க படிச்சதை ரிலேட் பண்றதுக்காக தான் இது மாதிரி நாங்க சொல்லி தரோம் so kindly try to understand fine so now what I am going to do I am going to use IC கரெக்ட்டா இப்ப IC ல போனா எனக்கு என்ன இருக்கும் HA இருக்கா செலக்ட் பண்ணியாச்சு how many half adders I need to construct a full adder how many half adders I need 2 so I want to take one more half adder okay so I am having two half adders so I need 3 inputs okay so 3 switches I am going to take okay then 2 outputs for that 2 light I have taken then 1 OR gate we need என்னென்ன வேணுமோ எல்லாத்தையும் எடுத்துக்கறோம் that's it so what we are going to do we are going to move the OR gate somewhere okay so here we will be having carry here we might be having you can rename as you require so we are having 3 switches so I am going to rename the switches so I am having 3 switches so first one is A second one is B the third one is C in னு கொடுத்துக்கலாம் C in carry in okay now the outputs are we are having 2 bulbs so one is sum I am making it as S the other one is carry so I am making it as C or simply I can write C naught okay so it become output carry in carry out fine so now I am going to take 3 nodes 1 2 3 3 node எடுத்தாச்சு so I am going to place nodes below each switches so I am going to connect A with the first half adder B with the second half adder now I am going to correct the nodes so nodes proper ஆ என்ன பண்ணிக்கலாம்னு சொல்லிருக்கேன் just என்ன பண்ணிக்கலாம் you can drag it. See, இந்த எக்ஸ்பெரிமெண்ட்ல ரொம்ப கஷ்டம்லாம் கிடையாது. How fast I am doing? Once you have practiced, you can do it. So first half adderக்கு கொடுக்க வேண்டிய கனெக்ஷன் முடிஞ்சாச்சு. கரெக்ட்டா? சரி, செகண்ட் half adderக்கு என்ன பண்ணனும்? The output from the first half adder sum is given as one of the input. Okay, I have given. Fine. Then what about the final sum? This one. Okay. See, எனக்கு path ப்ராப்பரா வரணும் அப்படினா you can use node. எங்கெங்கெல்லாம் தேவைப்படுதோ யூஸ் பண்ணிக்கலாம். ரெண்டு அவுட்புட் இருக்கா? For each output I am going to place one node. So from here I am connecting. So I am going to drag the node so that proper layout will be there. Okay. I hope everyone can see this, but it is smaller in size. Okay, fine. So now the last thing. So carry the third input. Okay, C in must given as a input to the second half adder. Second input நம்ம கொடுத்தாச்சு. சரி, நான் சொன்ன மாதிரி நோட் வச்சு நீங்க என்ன பண்ணலாம், எங்க வேணாலும் பார்த்து வந்து ரீஓரியன்ட் பண்ணிக்கலாம். ஃபைன். ஃபார் திஸ் ஆர் கேட், ஸோ ஒன் இன்புட் ஃப்ரம் யுவர் செகண்ட் half adder, the other input carry is from your first half adder. Fine. So this will be the final output of your circuit. See, எங்கெல்லாம் உங்களுக்கு path change பண்ணுமோ அங்கெல்லாம் என்ன பண்ணிக்கலாம், you can introduce nodes. So for proper path you can introduce nodes. Okay, so that's all about the circuit. Can you people type it in the chat? What about the output for 111? I'm asking a simple question. 111 க்கு என்ன output வரும்பா? 111. For the input combination 111, what about my output? Yes, sum is 1, carry is 1. Okay, 111. Whether it is working? Yes? Yes or no? Yes. Okay. Please remember one thing, students. You must use ICs. சரிங்களா? இந்த மாதிரி நம்ம என்ன பண்ணக்கூடாது, லாஜிக் கேட், பிளாக்ஸ் இந்த மாதிரி யூஸ் பண்ணக்கூடாது. You people mandatorily use ICs. சரிங்களா? உங்க கூகுள் கிளாஸ் ரூம்ல அந்த ஐசி பேக்கேஜஸ் எல்லாமே உங்களுக்கு அவைலபிள். ஃபைன். ஸோ ஐ எம் கோயிங் டு டூ ஃபுல் ஆடர் வித் ஐசி. சரிங்களா? சரி, இந்த மாதிரி நான் சர்க்கியூட்ஸ் வந்து பெர்ஃபார்ம் பண்ணக்கூடாது. இது உங்களோட அண்டர்ஸ்டாண்டிங்காக. லேப் எக்ஸ்பெரிமெண்ட் அப்படின்றது என்ன பண்ணணும், you have to do with only ICs. Fine. So this entire circuit you can convert it as a full adder. ஐசியா கன்வெர்ட் பண்ணா என்ன பண்ணணும், செட்டப்ல போயிட்டு ABC இன்புட்டா கன்சிடர் பண்ணிக்கணும், SCO அத அவுட்புட்டா கன்சிடர் பண்ணிக்கணும். That's it. Fine. So now I am going to implement the circuit with IC. பண்ணலாமா? So with that we will stop today's session. So அதோட ஸ்டாப் பண்ணிக்கலாம். Full adder using logic gate ICs. Fine. So I am not going to save this. So the project வந்து நான் என்ன பண்ணலாம், delete பண்ணிடலாம். If not needed, we can delete the project. Okay. So now I am going to delete. Fine. So new project. What are the things we need now? என்னென்ன கேட்லாம் வேணும்ப்பா ஃபுல் ஆடர் பண்ணணும்னா, என்னென்ன ஐசில வேணும்? We need what are the gates? Kindly type it in the chat. So with this I will stop. இந்த சர்க்யூட்டோட ஸ்டாப் பண்ணிக்கலாம். ஃபுல் ஆடர் சர்க்யூட் நான் பெர்ஃபார்ம் பண்ணா என்னென்ன லாஜிக் கேட் வேணும் நமக்கு? ஓகே, 2 XR, 2 and 1 R. Okay, so in single IC, single XOR gate IC, I'm having four XOR gate இருக்கு. So அதனால பிரச்சனை கிடையாது. அடுத்து we can go with AND gate IC. AND gate IC. Okay, then we need one OR gate IC. We need one OR gate IC. So I am having 3 ICs. So I am arranging in some fashion. Fine. So first நம்ம வந்து என்ன பண்ணலாம், சம்முக்கு உண்டான எக்ஸ்பிரஷன் பண்ணலாம். We need 3 switches, A, B, C in. So இது A ன்னு வச்சுக்கலாம். We will later rename it B, C in. Okay, what about the function for sum? Full adder பொறுத்த வரைக்கும் சம்முக்கு என்ன எக்ஸ்பிரஷன் பார்த்தோம்ப்பா? A, so this is the input A. So another 5 minutes la complete பண்ணிடுவோம்ப்பா. With this we will stop the session. Kindly bear with me. B, so the last one is C in. Okay, so for each thing we may use node so that proper connection will be there. So 3 node எடுத்துக்கலாம், 1, 2, 3. So 3 nodes we are going to use. So இது எல்லாமே 2 input XOR gate. கரெக்டா? அப்ப நான் என்ன பண்ண போறேன், ஃபர்ஸ்ட் A XOR கேட்டுக்கு ஒரு இன்புட் கொடுத்தாச்சு. ஃபைன்.
ஒண்ணும் இல்லடா.
B, someone unmuted. Deenadayalan. 209, roll number 209. வெளியில போயிட்டாரு. ஓகே.
He left, sir.
ஓகே மேம், தேங்க்யூ மேம். ஓகே, ஸோ ஏபி கொடுத்தாச்சு. கரெக்டா? இதோட XOR வேல்யூ எனக்கு எங்க இருக்கும், 1Yல கிடைக்கும். கரெக்டா? ஸோ திஸ் ஹேஸ் டு பி XOR with the third input C. ஸோ C கூட நான் என்ன பண்ணணும், how to perform ஸோ சம் எனக்கு எங்க கிடைக்கும், 2Yல கிடைக்கும். கரெக்டா? நல்லா கவனிச்சிங்க, தெரியும். A XOR B 1Yல கிடைக்குது. அதை நான் அவுட்புட்டா என்ன பண்றேன், அதை இன்புட்டா கொடுக்குறேன். செகண்ட் ஆர் கேட்டுக்கு 2Aல கொடுத்துருக்கேன். the third input C in 2Bல கொடுத்துருக்கேன். so the final output becomes available at 2Y. 2Yல எனக்கு அவுட்புட் கிடைச்சிரும். கரெக்டா? so that I have to give it to a LED. so light ஒன்று எடுத்தாச்சு. so I am placing it here. simply I am going to connect 2Y with that light. That's it. Is it clear for all of you? Sum முடிஞ்சது, இன்னும் கேரி மட்டும் தான் பண்ணணும். I am going to rename this. Rename it as sum. I hope sum எல்லாருக்குமே புரிஞ்சிருக்கும்னு நினைக்கிறேன். Any doubts up to this? Any doubts up to this? Yes? சம் முடிஞ்சது, புரிஞ்சுதுங்களா எல்லாருக்கும்? now we are going to do for carry. carryக்கு நான் என்ன பண்ணும்பா, what is the expression for carry? I will type it in the chat. You people observe. AB plus A XOR B and with C. Is it correct or wrong? Kindly you people check and tell me. Is it correct or not? AB plus A XOR B dot C. Is it correct or wrong? Correct. Okay. So what I am going to do, I am going to use the AND gate. So already I am having A. 1A la கொடுத்தாச்சு. I am having B. 1B la கொடுத்தாச்சு. AB கிடைச்சாச்சு. இன்னொரு AND term எனக்கு என்ன வேணும்? C in. Actually C கிடையாதுங்க, C in. A XOR B already available. A XOR B எனக்கு எங்க available? 1Y ல available. கரெக்டா? A XOR B is already available in 1Y. So from there, I am going to take to 2A. Sorry. From there, I am going to take to 2A and I am connecting. Fine? Okay. So what about the second input for the second AND gate? A XOR B ஒரு input கொடுத்தாச்சு. இன்னொன்று என்ன பண்ணணும்? C in கொடுக்கணும். கரெக்டா? So we have to give C in. That's it. So here we are having two outputs. 1Y, 2B. கரெக்டா? 1Y, 2B அப்படின்னு சொல்லிட்டு ரெண்டு அவுட்புட் நமக்கு இருக்கு. 1Y, 2B ரெண்டு அவுட்புட் நமக்கு இருக்கு. அது ரெண்டுத்தையும் நான் என்ன பண்ணணும்? I must be giving those two outputs to the OR gate. So connect 1Y, 1A ல கொடுக்கிறேன். So some mashup will be there. So I am going to use two nodes. ரெண்டு node யூஸ் பண்ணிக்கலாம். So I am taking one node here and another node here. So from here I am connecting to 1Y. This has to be connected to 1A. So this node, if I brought to this side, you can clearly see. So ஒரு input முடிஞ்சது. கரெக்டா? OR கேட்டுக்கு ஒரு input முடிஞ்சது. இன்னொரு input எங்கேருந்து வரணும்? I think there is a mess up with here also. Wait a minute. So I may use one more node for this connection. So I am going to delete this connection. Okay, I may use one more node. See, as much node you can use. So 1Y, from 1Y node connection எடுத்தாச்சு. So that is given to 1A. I hope now it is clear. Similarly, what about 2Y? 2Y must be given to 2B. இங்கேயும் ஒரு node தேவைப்படுது நமக்கு. Fine. We will take one more node. See, node எவ்வளோ வேணா நீங்க யூஸ் பண்ணிக்கலாம் உங்க ப்ராஜெக்ட்ல. No issues. So I am going to move the node in a way such that it should be proper way. So I need one more output as carry. Fine. Sorry, I have taken. So I need one more output for carry. So மேல சம் முடிஞ்சது. Okay. So connect this node with light and this one with 1Y. That's all. So you can move the carry near to sum. You can label it as C out. CO. Fine. So I am going to move the node in proper way. Should be like this. So the entire circuit looks like this. Correct? Okay. So now we will check the output. 1 1 1 கொடுத்தா நமக்கு என்ன வரணும் சொன்னோம்? Output is 1. Both outputs are 1. Say for example 1 0 1. Sum 0, carry 1. Fine. 1 0 0. Sum 1, carry 1. Fine. 0 1 1. Sum 0, carry 1. Is it clear for all of you? Yes? So with this we will stop today's session. Any doubts? Okay. Now I am going to stop the recording.